Hello students, welcome to example 5 of week 8. So in this example we will be making this spiral. So for this spiral there are very few dimensions actually given, but there is a whole note that says how it should be made. So we can start reading the note. So basically the profile of the helix and spiral is a 9.8 millimeter circle, so that would be basically this circle and that circle, or basically the whole spiral. Then the bottom spirals from a diameter 10 millimeter circle to a 100 millimeter diameter circle. Each 180-degree turn of the spiral moves to a 10 millimeter larger diameter circle, and then this is just the dimensions to make the helix. So basically the spiral refers to this bottom part and the helix is the upward part, basically because we're going to use the helix feature to make this upwards part. And then what's also important to note is the direction in which it turns, and then you'll see this is the bottom view. So when drawing it, you should either orientate your sketch so that you're also looking at from the bottom view, or you should just draw everything in reverse to ensure that it is correct. So then I'm going to start with this part. Then now I'm going to start with a sketch. I'm going to do it on the top view, but then before actually sketching, I'm just going to change this so that I'm viewing it from the bottom. So basically my X is here and my Y is going downward, the same as in the sketch that was given. Okay, then I'm going to put in those 10 millimeter to 100 millimeter diameter circles. So we're going to use them to make the spiral, and I'm also going to convert them to reference lines later. Okay, so this is all of the circles. Then now I'm just going to select all of them, and then I'll turn them into reference lines at the same time. So I just select the convert to reference. Alright, so now I can actually start drawing the spiral. So its starting point was given to be 5 millimeters above in the y, or in the negative y direction. So it will obviously be at the top here on this circle. So I'll just select that as my starting point for this arc, and then it was stated that each 180-degree turn of the spiral moves to a 10 millimeter larger diameter circle. So basically if this is my starting point of the arc, then for 180-degree turn the arc will go like this, and then it will stop at this circle that is 10 millimeters larger. So now I just want to make sure it places it correctly, so like that. Okay, so my start point isn't actually on this circle, so I'll just select this point, select this arc, and then make it a point on curve constraint. And then also I just have to actually put in a constraint so that this point is in line with the y-axis. So I just select a point and I select this midpoint, and then I'm going to line them vertically. Right. Then when inserting this arc here, the tangent constraint to this circle was automatically put in. Now I just also need to put in a tangent constraint between this the arc and this circle. So each of the arcs we're going to put in will have to be tangent to both the circles on which it is. Right. So then for the next arc, it's going to go like exactly the same. So I start at this one's endpoint, just making sure that I actually select the point, and then for 180-degree turn, it goes to a 10 mm diameter circle that is larger than the start. So there, and then I just want to position it correctly. Okay, like that. Just have to actually put this point on this arc, like that. Then yeah, and then I should make this arc tangent to the circle, and then I still have one auto dimension. So I think what happened here was when I put in this selected the start point, it didn't actually select this point, it just selected the arc or the circle. So I just have to make these 2 points coincident. So I just select them and select the coincident constraint. And then after each arc, I'm just checking that my sketch is still fully constrained. Okay, so this is basically going to continue for all of the arcs. So I'll just continue putting them in. Okay, and my sketch is still fully constrained. So each time you should just check to which circle it put in a tangent constraint automatically, and then just for the other one you will also then have to put in the tangent constraint. If you didn't put in any tangent constraints, then you will have to put in both of them. Okay, so I accidentally put in one too much constraint. So it's saying it is over constraint. So I'm just going to Control Z and see what the problem is here. And well, when I tried to pull this line to see how it moves, it made it tangent to the circle, which is actually what I wanted to do. And when it said it was over constraint, now my sketch is fully constrained. So yeah, that worked out good. So I'm just this will now be the second last arc. Okay, so just selecting the start point here, and then the end point. And the 2 arcs should be tangent. Okay, and then the last arc. So so this is the end point. Okay, and the sketch is fully constrained. And then if you compare to the given sketch, it showed that the endpoint should be here in the direction of the y-axis downward, and this is where it is, so we know it is correct. So now I can say finish. Now I'm going to draw the circle that is the profile of the spiral. So I'm going to make another sketch. I'm going to make it on the right side because it is perpendicular to this both the end point and the start point of the spiral. So basically the profile should be perpendicular to the spiral for it to be correct. Right, then I'm just going to hide this previous sketch so that I don't select one of those points when I constrain the circle. So it should be 9.8 millimeters. Its midpoint should be in line with the sketch origin, and the distance between the sketch origin and this one's midpoint should be basically 50. So on the sketch it was given as the starting point and end point is 55 millimeters from each other, and the starting point is 5 millimeters from the origin. So then obviously the distance between the origin and the end point is 50 millimeters. And the sketch is fully constrained, so now I will just say finish, and I will just unhide my sketch, and this is how it looks, and you'll see it is perpendicular to this spiral. So now I'm going to use the swept function, which is under the surfaces tab. Then the first thing is to select is sections, and so this curve would be basically the profile that you want to sweep. So this would be my circle. Then next you have to select the guides. So this would obviously be the spiral, and my selection here was on connected curves, so it just automatically selected all the curves. If it was on single curve, then you will have to select each one individually, or you can just put it on connected curves and it will select the whole spiral. And then I don't have to change any of the other settings. So that's fine. Then I just say okay. And so now that the bottom spiral is done, I can make the helix. So the helix we're not going to draw, but we're going to make it using a function which is under curve. It is the helix function. Okay, so in the helix function, before starting, I'm just going to hide my swept so that it's easier to just put the helix in the correct position. So the first thing I'm going to do is in the sketch, the turn direction was given. It was stated that the helix has a left-hand turn direction, so I'm just going to change that first. So basically under the settings heading, you can just expand it, and then in the turn direction select the left-hand one. Right, so that's because that's going to make things easier. Then I'm just first going to insert the values before I orientate the helix in the correct position. So the diameter was given, so the diameter is under the size heading, and the diameter was given as 100 millimeters. Then the pitch of the helix was given as 10 millimeters, and then the length was given as 100 millimeters. So okay, so its dimensions is in. Now I just have to put it in the correct position, because my helix has to start here where my spiral ended. So I'm just going to use these little thingies to rotate my helix into the correct position. So basically I just want to rotate this one 90 degrees like that. Then you if you zoom in, you'll see that the helix starts like exactly there in the center of the circle, which is where we want it. So then I can just say okay. Now I'll just unhide my sweep, and you'll see it the helix just continues from out of the sweep. that's how we want it. So now I'm basically just also going to sweep how I did for this bottom spiral. I'm just going to sweep the helix as well. So I'll just go to the sweep function again, which is on the surface. So I'm just going to hide this sweep again, just so it's easier to select the circle. So then once again, the sections, the select curve would be this circle here, and then the guides, that will be the helix. Okay, and then I don't want to change any of the other settings, so I just say okay. Okay, so now I'm just unhiding my bottom spiral, and I'm just going to hide this sketch. So now these two are still two separate pieces, so I'll just unite them so that they are one body, basically like that. Okay, and so basically, yeah, this circle doesn't it still kind of looks like it's two pieces, but it is one body. So basically, when I go to the measure function and my selection folder is on solid body, I select it, it basically selects the entire spiral or spiral and helix. And then I'll just put in my properties. So it's the surface area, the center of mass, the mass, and the radii of gyration. And then before I go and compare to the memo part, I didn't actually put in a material yet, so obviously it's not going to be right yet, correct yet. So I'm just going to tools or menu tools, materials, and then assign materials, and the material was specified to be brass. So I just apply it and say okay. And well, I didn't actually check, but it probably updated this. I'm just going to say Control Z and check if it updated it, because I put on the automatic update. So basically just the mass changed when I changed the material, which makes sense. Right, so now I'll just quickly compare to the memo part here. So basically the mass 2.4622, here is also 2.4622, and then for the other dimensions, when I compare, the rate of gyration looks correct, center of mass also looks correct, and then the surface area also correct. So yeah, so now I know my part is correct, and yeah, then that's the end of this example. I hope you also go and try it. It's quite a simple example. It's a little different from the rest of the examples and so on, but yeah, I hope you give it a try, and good luck with the rest of the examples.